Is it perfect? You should put it inside. Okay. Hi, YouTube. Welcome. So I'm gonna be using this live video in order to study because I have an incoming test. So I have to be ready. I don't know. Maybe I should close the window because of the noise. Okay, I'll be right back right now. Close this. All right. All right. That's much better, right? All right. So I'm not gonna be doing a lot of things. I'm just gonna be studying. That's what I'm gonna be doing, and I'm gonna end this live when I stop studying. And that's it. Maybe I should put this here so that you can see me properly. Hi guys. Yeah. Ooh, this is my first time doing a live, and I'm so excited. Oh my gosh. Hi. Hi guys. Yeah. So I don't know if my camera quality is okay, but yes. Let's go. Let's go. I don't want you to see my face because I'll be studying. Yeah. This is the stuff that I'm going to be using. Right. Is it good? Is it enough? Is it enough? Right. Okay. Right. Well, it's better than nothing, honestly. It's better than nothing. Okay, I'm gonna be starting using my phone, and what else? That's it. I'm gonna be starting using my phone. So let's go. So yesterday, thing about I was studying. It's not to be included. We know that everybody is somebody's There's the proof. Show me your proofs. The proof of the day. Sure. I'm really sure. Engage you. Okay. Determine if that is horizontal.
Sequence. To show that it's always increasing, we need to show that the first term is less than or equal to the second term, or to say the second term is greater than or equal to the first, and the third term is going to be greater than or equal to the second, and so forth. You could also show that the first term divided by the second term is less than or equal to 1. So that's a monotonic increasing sequence. And to show that the sequence is always decreasing over time, you can use this. A sub 1 has to be greater than or equal to A sub 2. And the second term has to be greater than or equal to the third term, or the third term has to be less than or equal to the second, and so forth. And so, if you focus on this part of the inequality, where A1 is greater than or equal to A2, if you divide both sides by A2, you'll get this expression. A1 divided by A2 is greater than or equal to 1. So there's different ways you could show that this is a monotonic decrease in sequence, and this is a monotonic increase in sequence. Now let's draw a graphical representation of an increasing monotonic sequence. So here you can see the terms in the sequence, they're always going up. So that's an increase in monotonic sequence. Here's an example of a decrease in monotonic sequence. Now what about this sequence? Would you say it's a monotonic sequence? Notice that there's no general trend. It's not going up or down, it's actually doing both. It goes up, down, up, down. So the long-term trend is basically just staying around that midline. And so it's not increasing in the long term. Decreasing in the long term. So therefore, this sequence is not monotonic. Now let's work on an example problem. Consider the sequence A sub n is equal to 3n divided by n plus 2. So is this a monotonic sequence? And if it is it always increasing or decreasing? Well, first, let's get a general feel for the sequence by listing out the first 4 terms. So the first term, A sub 1, is going to be 3 times 1 divided by 1 plus 2. So that's 3 divided by 3, which is 1. So I'm going to write that here. First term is 1. Now the second term, that's going to be 3 times 2 over 2 plus 2. So that's 6 over 4, which we can reduce that to 3 over 2. Now the third term, that's going to be 3 times 3 over 3 plus 2. So that's going to be 9 over 5. And the fourth term, 3 times 4 divided by 4 plus 2. So that's 12 over 6, which is 2. Now let's get the decimal values of all the fractions for those terms. So 3 over 2, that's 1.5. And 9 divided by 5, that's 1.8. So we have a monotonic sequence. We can see that it's always increasing. Now how can we prove that it's always increasing instead of just plugging in the numbers? Well, we need to show that the second term is greater than the first term. But we need a generalized way of doing that. So we need to show that A sub n is less than or equal to the next term, which will be A sub n plus 1. So if we can show that this statement is true, then we can show that every other term is going to be increasing. So we can also show that A sub 2 is less than A sub 3, A sub 3 is less than A sub 4, and so forth. So let's go ahead and replace A sub n with 3n over n plus 2. Now,
when I'm trying to explain something to somebody and I just don't have all the words that I need, it's at the tip of your tongue, it's just out of reach. When I first started using Elevate, it was a revelation.
It's A sub n. What is A sub n plus 1? So everywhere we see an n, we place it with n plus 1. So this is going to be 3 times n plus 1 divided by n plus 1 and then plus 2. So all we need to do is show that this inequality is true. If it is true, that means that the original inequality is true. And that's how we can show we have an increase in monotonic sequence. So first, let's simplify the expression. On the left, we have 3n over n plus 2. On the right side, I'm going to distribute the 3. So it's going to be 3n plus 3. And then on the bottom, I'm going to add 1 plus 2, which is 3. So that's just going to be n plus 3. Now, what we're going to do is cross multiply, which is equivalent to first multiplying both sides by n plus 3. So then on the right side, these will cancel. And then multiply both sides by n plus 2. So on the left side, these will cancel. So we're going to have 3n times n plus 3, and that's going to be less than or equal to 3n plus 3 times n plus 2. Now let's go ahead and distribute the 3n to n plus 3. So 3n times n, that's going to be 3n squared. And 3n times 3, that's 9n. And then on the right side, we have 3n times n. So that's 3n squared. And then 3n times 2, so that's 6n. And then 3 times n, 3n. And then 3 times 2, which is 6. So subtracting both sides by 3n squared, we can eliminate this term. So we have 9n, which is less than or equal to 6n plus 3n, that's 9n. And then if we subtract both sides by 9n, we're going to have 0 is less than or equal to 6. Now, is that a true statement? Is 0 less than 6? Yes, it is. So because this statement is true, the original statement that we started with, which was a sub n is less than or equal to a sub n plus 1, well, that's also a true statement. And that's how we can prove that we have an increase in monotonic sequence. Now let's work on another example. So let's say we have a sequence a sub n is equal to 3 over 4. So let's go ahead and replace a sub n. N plus 2. Now let's go ahead and distribute the 3n to n plus 3. So 3n times n, that's going to be 3n squared. And then 3n times 3, that's 9n. And then on the right side, we have 3n times n. So that's 3n squared. And then 3n times 2, so that's 6n. And then 3 times n, 3n. And then 3 times 2, which is 6. So subtract both sides by 3n squared, we can eliminate this term. So we have 9n, which is less than or equal to 6n plus 3n, that's 9n. And then if we subtract both sides by 9n, we're going to have 0 is less than or equal to 6. Now, is that a true statement? Is 0 less than 6? Yes, it is. So because this statement is true, the original statement that we started with, which was a sub n is less than or equal to a sub n plus 1, well, that's also a true statement. And that's how we can prove that we have an increase in monotonic sequence. Now let's work on another example. So let's say we have a sequence a sub n is equal to 3 over 4 raised to the n power. So is this a monotonic sequence? And if it is it increasing or decreasing? Well, let's make a list of the first 4 terms, just to see what's going on. So the first term, a sub 1, that's just going to be 3 over 4. The next term, when n is 2, 3 squared is 9, 4 squared is 16. And then the third term, when n is 3, 3 to the third power is 27, 4 to the third is 64. And then for the fourth term, 3 to the fourth power is 81. 4 to the fourth power is 256. Now let's get the decimal values for these fractions. So 3 over 4 is basically 0.75. 9 over 16, that's 5625. 27 over 64, we're going to start rounding these, so that's 0.4219 approximately. And then 81 over 256 is approximately 0.316. So we can see that the numbers are getting smaller and smaller and smaller. So the first term is greater than the second term, or the second term is less than the first term. So this appears to be a decreasing monotonic sequence. Now how can we show? So we need to show that a sub n is greater than or equal to the second term or the next term, a sub n plus 1. Now in this case, I'm going to divide both sides by this term, a sub n plus 1. So a over n, a sub n divided by a sub n plus 1, that has to be greater than or equal to 1 to show that this is a decreasing monotonic sequence. Now, let's go ahead and replace a sub n with 3 over 4 raised to the n power. And then let's replace a sub n plus 1 with 3 over 4 raised to the n plus 1. Now let's show that this is greater than or equal to 1. Feel free to pause the video and try it. So what do you recommend that we do?
Tell me why I'm on me.
In order to show that it's greater than or equal to 1, we need to split this into two parts. So 3 over 4 raised to the n plus 1, we can write it as 3 over 4 raised to the n times 3 over 4 raised to the first power. Because when you multiply by two common bases, you can add the exponents. N plus 1 is equal to n. So now, in this form, we can cancel 3 over 4 raised to the n power. And so we're left with 1 divided by 3 over 4. And let's show that it's greater than 1. So we're going to multiply both sides, the top and the bottom, by 4 over 3. 4 over 3 times 3 over 4, that's 1. The 4's cancel, and the 3's cancel. So all we have left over is that 4 over 3 is greater than or equal to 1. Is that a true statement? Yes, it is. 4 over 3 is about 1.3 repeated, and that's greater than 1. So therefore, our original statement, that is a sub n, is greater than or equal to a sub n plus 1. That is a true statement. So this proves that we have a decrease in monotonic sequence.
Alright. Oh, because diagonally there's a decrease division in this one. Without doing what he did by multiplying and doing the shape. It just, it's 4 over 3. Yeah. No, 4 over 3 is greater. Decreasing.
Monotonic sequence. Now how can we show it? So we show that a sub n is greater than or equal to the second term or the next term, a sub n plus 1. Now in this case, I'm going to divide both sides by this term, a sub n plus 1. So a over n, not a over n, but a sub n divided by a sub n plus 1, that has to be greater than or equal to 1 to show that this is a decrease in monotonic sequence.
That has to
Now, let's go ahead and replace a sub n with 3 over 4 raised to the nth power. And then let's replace a sub n plus 1 with 3 over 4 raised to the nth plus 1. Now let's show that this is greater than or equal to 1. Feel free to pause the video and try it. So what do you recommend that we do in order to show that it's greater than or equal to 1? We need to split this into two parts. So 3 over 4 raised to the n plus 1, we can write it as 3 over 4 raised to the n times 3 over 4 raised to the first power. because when you multiply by two common bases, you can add the exponents n plus 1 is equal to them. So now, in this form, we can cancel 3 over 4 raised to the n power. And so we're left with 1 divided by 3 over 4. And let's show that it's greater than 1. So we're going to multiply both sides, the top and the bottom, by 4 over 3. 4 over 3 times 3 over 4, that's 1. The 4's cancel, and the 3's cancel. So all we have left over is that 4 over 3 is greater than or equal to 1. Is that a true statement? Yes, it is. 4 over 3 is about 1.3 repeated, and that's greater than 1. So therefore, our original statement, that is A7 is greater than or equal to A7 plus 1, that is a true statement. So this proves that we have a decreasing monotonic sequence.
Yeah. Can I pause this? I want to go to the toilet. Or can I end this stream? Okay, I think I'm gonna end this and continue studying because, but I just wanted to post content on my channel. I hope you guys continue to like, comment, and subscribe to my channel. Yeah, so I'll see you guys next time. Bye.